Welcome back. In today's session, I am Professor Fayaz Khawani from Department of Mechanical Engineering. With continuation with previous session, today we are going to discuss what are the conditions to avoid interference. These conditions we are going to understand by solving two numericals in unit number spur gear. See this figure we have already studied in previous session. In brief, I explain what is interference, so that we can understand the next thing, the conditions for avoiding the interference. See here, AB is the maximum path of contact, where EF is the path of contact only. FP is path of approach and PE is path of recess, when pinion will rotate in clockwise direction, at the same time gear will rotate in anti-clockwise direction. Now, what is interference? If the radius of addendum circle of gear is increased, the point of contact F will move from F to B. See here, when the radius, addendum circle radius RA, this addendum circle radius, where it cut the common tangent line at point F, this F point, if moves up to point B, this F point, if that radius is further increased up to point B, that is the maximum addendum circle of gear. See here, maximum addendum circle of the gear up to point B. But when that radius is further increased, that RA is further increased up to B, and if it is further increased beyond maximum radius of gear, that point F will move inside the base radius of pinion. This F point, that is the maximum limit of F up to B, but when that point F will again move, and it will move inside the base circle, the involved profile, this F point of this profile of gear is start undercutting the root diameter, root face of this pinion, and the involved profile will become non-involved. So undercutting the root diameter or root circle by this tip of that gear tooth, it will start digging the surface of the involved surface of that pinion tip. So this conversion of involute into non-involute is called interference. So interference will occur only if, see here, interference will occur if that F point exceed or move beyond that point B. So first condition is if PF is greater than PB. PF, that is a path of approach. If it exceeds the limit PB, that means length of PF will greater than PB, interference will occur. The same thing here also, happen here also. EP, path of recess, when that EP is greater than PA, beyond A, it will start digging the involute profile beyond A, and it will move inside the base circle of gear. So A and B are the point of interference. Beyond that point, interference will take place. So first condition is path of approach. If path of approach is greater than PB, path of approach is greater than PB, path of approach is greater than PB, interference will occur. The same thing happen here also. If path of recess is greater than AP, interference will occur. That is the condition of condition number 1. Second condition, RA, addendum circle radius for gear, if that is greater than RA max, at that time interference will occur. RA, addendum circle radius for gear, this RA greater than RA max, this RA max, maximum up to point B. Beyond that, interference will occur. So RA, if increase up to RA max, interference will not occur, but RA will be greater than RA max. That means O2B, that is RA max. Beyond that, interference will occur. Same thing here also. RA, this addendum circle radius for pinion will exceed O1A, that is RA max. Beyond that, interference will occur. And third condition, if teeth on pinion or teeth of gear will be greater than minimum teeth on pinion, at that time the gear is designed in such a way that the teeth, or to avoid the interference, there will be minimum number of teeth. There should be minimum number of teeth. If the teeth on pinion will exceed the minimum number of teeth on pinion or gear, at that time interference will occur. So one by one, we are understanding the concept by solving the numericals. Is that clear? So come to our problem number 1, which is related with condition 1. Minimum path of approach should be if greater than PA, at that time interference will occur. So problem statement is that 220-degree involutes per gear have a module of 8 mm. The addendum of pinion and gear is standard. The number of teeth on pinion are 20 and teeth on gear are 40. And the question is, does interference will occur or not? That question was asked in the examination for 6 marks. And in the examination, one problem will compulsory come on interference. That decision you have to give whether interference will occur or not by satisfying these 3 conditions. By satisfying, you have to satisfy either condition number 1 or condition number 2 or condition number 3. That will depend on as per the given data in the questions. You have to satisfy either one. So now we are solving the problem on condition number 1. We have to satisfy this condition. If this condition is satisfied, interference will occur, and if that condition is not satisfied, interference won't be occur. Okay. Now model M is equal to 8 mm, pressure angle phi 20 degree, addendum AP, A suffix P is equal to addendum of pinion and gear is standard. That means standard is 1 module. Standard means 1 module. If that is different module, addendum is different, at the time in the question that is given, addendum is 1.5 module, addendum is 1.1 module, but here it is given addendum of pinion and gear is standard, that means 1 module. Okay, understand this thing. So 1 module is nothing but 1 into module 8, which is equal to, again, addendum for gear and pinion is 8 mm. Okay, teeth on pinion TP 20, teeth on gear TG 40. Now, as we learn in the terminology, module is equal to ratio of d by t. Here, module small d by small t for pinion. So module is given 8, and d we have to find out. Number of teeth on pinion is given 20. So pitch circle diameter will become here 160 mm cross multiplication. So pitch circle radius will become here 80 mm. Now module is again for gear capital D by capital T. So module is given for gear also 8. So capital D we have to find out divided by number of teeth on gear is 40. So pitch circle diameter will become 320 mm. So pitch circle radius is half of 320 is 160 mm. Second thing we have to find out addendum circle radius of pinion RA is equal to pitch circle radius plus addendum, as we learn in basic terminology of spur gear. And if you don't remember, I will share the link for terminology of spur gear. Okay, R is given 80 mm. R we have found out 80 plus addendum is given. Addendum is one module, so addendum is 8. So total is 88 mm. Same likewise here, addendum circle radius of pinion for gear is capital R plus addendum. So capital R is 160 plus 8 is equal to 168 mm. Now path of approach is equal to this. Already we have studied what is the formula for path of approach, under root RA square addendum circle radius for gear square plus R square cos square phi out of bracket minus R sin phi. So after putting the values of RA, R and pressure angle, we are getting the path of approach FP is equal to 20.23 mm. Okay, now next thing BP, we have to find out BP. What is BP? Again come to here, BP. This is BP. For finding BP, we are considering this triangle O1PB. O1PB. So this is phi. This angle is phi. Okay, and O1P is pitch circle radius small r. So as per trigonometric rule, we have to find out PB is equal to R sin phi. Small r sin phi. PB is equal to small r sin phi. So come here, small r sin phi. So value of small r is 80, sin 20. So answer is getting the length of BP is equal to 27.36. So interference will occur if, as per condition number 1, path of approach is greater than PB. PF is greater than PB. But here we are getting PF 20.23, which is smaller than 27.36. PB here 27.36. Okay, so this condition if happening, interference will occur, but that condition is not satisfying, so interference does not occur. Clear? So this condition is not satisfying, that means interference does not occur. Now come to our second problem. Problem number 2 for satisfying condition number 2. That question was asked in October examination in same. The paper number is 158 in SPPU University. Location problem statement is 220-degree involvers per gear have a module of 10 mm. The addendum of pinion and gear is one module. The number of teeth on pinion are 13 and on gear are 15. So question is asked here, does interference occur? And if interference will occur, then what should be the new value of pressure angle to avoid interference? That means we have to find out new phi pressure angle to avoid the interference. That question was asked in for 6 marks. So module is given 10 mm, pressure angle 20 degree, addendum AP is equal to AG, addendum for pinion, and here is standard. One module is again given. So AG and value of AG and AP is equal to here coming 10 mm. Teeth on pinion is 13, teeth on gear is given 50. Now, as per formula of module, the number of teeth on pinion is given 13. So pitch circle diameter is become here 130. So pitch circle radius half of 130 is 65 mm. Again, to find out the pitch circle diameter for gear, so pitch circle diameter for gear is coming 500, 10 into 50, that is 500. So pitch circle radius will become here half of 500 is 250 mm. Now the addendum circle radius of pinion RA is equal to pitch circle radius for pinion plus addendum is 75 mm. We are getting here addendum circle radius for gear. Some small mistake here. RA is equal to capital R plus A. 250 plus 10 is 260 mm we are getting here. Okay, now maximum radius of addendum for gear. Maximum radius. This is RA. This is RA. O2F is RA. And maximum addendum radius, that is O2B. O2B. Okay. If R max, if RA is exceeding, is greater than RA max, at that time interference will occur. That is our condition number 2. Okay, so we have to find out RA max, that is nothing but O2B RA max, because B is point of interference. Beyond that limit, interference will occur. Okay, so we have to find out RA max. For finding RA max, I am considering the triangle O2AB, this one. In the triangle, we can find out O2B. This formula, understand this formula clearly so that we can find out RA max. For finding RA max, I am repeating again, for finding RA max, this is RA max, O2B. For finding O2B, I am considering the triangle ABO2. ABO2. O2A is perpendicular to AB. So this angle is 90 degree. So O2AB is right angle triangle. So I am applying Pythagoras theorem here. RA max. I have to find out RA max. Okay. So summation of this square of this length plus square of this length, AO2. Okay. So what is AO2? AO2, for finding AO2, I am considering APO2. APO2. This angle is phi. Okay, and this length is capital R. Okay, so this length will become R cos phi. Capital R cos phi in this triangle APO2. APO2. This angle 90 degree. This angle is phi. This much. Okay, so as per trigonometry rule, this length is capital R. This is phi. I have to find out AO2. So AO2 cos of phi is equal to adjacent side divided by hypotenuse. So O2A will become R cos phi. Okay, R cos phi. Now I have to find out AB. AB is addition of AP plus PB. AP plus PB. So what is AP? Again, same triangle O2AP. This will become again R. So this will become R sin phi. R sin phi. Capital R sin phi. Capital R sin phi. And for finding this, I am considering triangle PO1B. PO1B. Again, this is right angle triangle. This angle is phi. So PB will become small r. This is small r sine phi. This length. Okay. So AB will become addition of AP plus PB. So AP is capital R sine phi and PB is small r sine phi. Okay, so as per, so this total length I have find out, this length I have find out. So applying Pythagoras theorem, O2B RA max is equal to under root this plus this, under root O2A plus AB, AB square, this square. So the formula will become here to find out RA max here. Okay, this r cos phi is this one. Okay, and this capital R sin phi plus R sin phi, small r sin phi, bracket square, this will become this AB. So applying Pythagoras theorem, RA max or 2B is equal to under root d square plus d square as per Pythagoras. So by putting the value of, we have all the values of capital R, phi, small r. Already we have found out. So RA max is equal to, by putting all the values and solving this equation, the RA max we are getting here 258.44 mm. Okay, so interference will occur if, as per condition number 2, RA, this RA, this RA, sorry, this RA exceed RA max. So what is RA? R suffix A is 260 here. RA, random circle radius for gear, 260. If RA is greater than RA max, at the time interference will occur. The condition is satisfying here. 260 is greater than 258.44. So interference will occur. Okay. So next question is asked here. If interference will occur, what will be the value of pressure angle to avoid interference? So to avoid interference, new value we have to find out. So I am writing here phi mu. So at 258.44 RA max, at that value interference is occurring. So if I am taking 260 as RA max, 260 random circle radius of gear, I am taking RA max. So we are checking that whether to that condition interference won't be occur. So I am taking, instead of RA max 258.44, I am taking RA max 260. So 260, all the values of R, this R and this small r we have, only we have to find out phi. So one unknown is there here, one unknown is there. By solving that equation, one unknown is only there in the equation. By solving, squaring both sides, this RA max to 60 square, and at that time if you square all this whole bracket, this root will go cancel, and R cos phi plus R sin phi plus this small r sin phi, and then only phi, one unknown is there. By solving this numerical, RA max 260 mm, we are getting phi, pressure angle nu to avoid the interference is 21.86. That will be the answer for finding new pressure angle for to avoid the interference. Clear? Now at the end of this session, student can understand what is interference, and student can solve the numericals on interference. In next session, we are going to understand, we will study the minimum number of teeth to avoid the interference, what is the formula for that, and what and we will solve one numerical to understand that concept. Okay, thank you so much. And if you have any question, you can write in comment box. Thank you so much.